equation, and the other equation is parallel to there's an unknown equation, and the equation is parallel to this equation. So from the gradient we saw before, we can establish that if they're parallel, that means that they have the same gradient. And so we can assume that the gradient here is 3. That doesn't look like a tree.
Try use a thinner pencil.
No, I made too much. Yeah, screw it. I'm just gonna cross it out. Okay, equals to 3, and then also this. So to find the equation, you just need to insert this again. And so this is the same as the question before. You get 4 equals 3 plus c. And by moving this to the other side, you get 4 minus 3 equals c. And you find that c equals to 1. And then to find the equation of the other of the find the unknown equation, you just need to put in the gradient and the c, and that's it. So we have covered this one.
I can scroll down.
Oops. Okay, I'll just clear the entire thing here. So for the next question, we're gonna next question is that the equation is perpendicular to y equals minus 2x plus 1, and it passes through minus 1, 5. And like the properties before, we can note that m1 equals to 1 minus 1 over m2. So if m1 is equals to minus 2, that means to find m2, we're going to have to move this algebraically, and that's how you get m2 as 1 over 2. And then like before, you just need to insert the equation to find, again, you just need to find the c, and you just need to insert the equation to find that. Equals to 5 minus 1 over 2 plus c. So that's 3 plus 1 over 2. C equals to 3 times 2 equals to 7 over 2. And then again, you just need to find the final equation, you just need to insert the gradient and the c, which is y equals to 1 over 2x plus 7 over 2. So for the next question, we're supposed to find the shaded area. Okay, this might be a little bit trickier than the ones before. But it's actually quite simple. So what's going on here is okay, so what's going on here is that you have to find to find the shaded area, you have to find this. And you also need to find this. And then with that, you can find the area of this. And then to find this, you need to find this length, you also kind of need to find this point. And to find this point, you sort of need to find the equation of this entire thing. And to get that, you firstly have to find the equation of this thing. And we can do that since we have 2 points, here and here. And these are the 2 points. This is the x-intercept. And this is the intersection. And with this, we can find the gradient by using the rise over run. Which is 0 minus 12 over 6 minus 3. So that would result in minus 12 over 6 plus 3. So you get minus 12 over 9. And to simplify, you get 4 over 3. And then to find the... Okay, so there are 2 ways in the way you can find the equation. You can do it through the y2 minus y1 form, this format, or you can also go through the y equals mx plus c format. So because I've been doing this one, I'm going to work on this format.
Yes. It just popped up.
Oh.
Sorry. Go ahead.
Okay, it's okay. So how you find this is that you insert one of these. For example, if I want to insert this, it's gonna be 12 minus y equals to m minus 3 minus x. And you just need to you just need to do this by algebra, basic algebra. You just oh yeah, don't forget to insert the m. The m is minus 4. Let me just redo this somewhere else. 2x 12 minus y equals to 4 over 3 times minus 3 minus x. And that gets you minus plus 4 and then plus 4 over 3x is 12 minus y. So if you move 12 to the other side, you get 4 over 3x plus 4 minus 12. And if you move this thing to the other side, it becomes minus 4 over 3x plus 8. And since you need to find the other side of it, this is just like kind of like for bonus. You don't technically you don't have to find the equation of this. You can just find the gradient right here, and then you can just jump into it and use 3 over 4 to find the equation of this side, which would be by using this. So This is minus 3. This is 12 plus C. 3. So you get minus 3 equals to 9 plus C. And if you move it to the other side, you can find that C equals to minus 12. And through this, you can find that this particular equation would be y equals to 3 over 4x minus 12. And that's how you get this part, this x-intercept, by inserting y into 0. So if you move this to the other side, you get 12 equals to 3 over 4x, and then you multiply it by 4 over 3, side 2, 4 over 3, cross it out. And for this, you also cross it out. And that's when you can get x equals to 16. So now you know that this part is minus 16 over 0, because did I do something wrong here?
4 over 3?
It's 4 over 3. Okay, so, I mean, there's nothing wrong with the minus 4 over 3 part, since minus 4 over 3 is supposed to be for this gradient. Because, like, since this is perpendicular, that means that you have to switch it. You have to do the m1 equals to minus m2. So you switch it and it turns into 3 over 4. And then after you insert, you get I think this is okay. Yeah, I think this is supposed to be positive. It's not
Like
supposed to be
here,
negative.
you rearrange, but they switch. I might just be bad at math.
Oh, there's nothing wrong with this, because I'm just moving this here
Okay.
by doing this and this. No, I think my issue is this part, because if I'm trying to look for the y-intercept of this, it's supposed to be positive, not negative.
Mm-hmm.
The numbers might be correct, but it should be positive. So maybe I should just clear this and everything. There. Oh jeez. Minus 3 over 12. Oh, by the way, one of my friends wanted to join. Wait, let me just send the invite link of the IB Math. Okay. I guess I'm gonna redo this and so assuming this by 12, 0 minus 3. Wait, no, this is okay. This is 6, 0. I'm so sorry. So it's supposed to be 0 minus 12, 6 minus 3. There. That's, yeah, that gives you minus 12 over 9. So that's 4 over 3 and minus 4 over 3. So the other gradient would be equals to 3 over 4. And then you insert it into the general point intercept equation. Find C. 9. Okay, that's very weird. Wait, this is, no, this is not 9. Okay, yeah, this is very weird. I can't tell if I did something wrong or not, but this is technically how you're supposed to do it.
Alright. And we can just move on. Try another example.
Oh, basically, yeah, because this is like the faster version of what I'm trying to do. You see the find. Wait, let me just. Oh, so, oh, hi, Will. Okay, so we're actually working on one of the questions right here. No, I was working on one of the questions and I couldn't solve it yet. I can't tell if I did something wrong. Let's use integration. Why would you use integration in this thing? Okay, I can't. You know, let's just skip that question. I don't want to waste so much time in that question. Okay, now we're going into graphing a straight line. Oh man, I so want to do this in my in my art software, but screw, it's not. Okay, so to graph the equation, you kind of just have to reverse engineer the equation itself and figure out yeah, and kind of like figure out what is what. So for example, in the case of y equals mx plus c, we know that this is the y-intercept. And from this, we can know that if you have, for example, a straight line like this is going to be 0c. This is going to be here. And then the slope would be m. For example, if, let's just say, if the slope is 2, so that means every one coordinate that you move 2 times for the the y coordinate. So for example, if this from here to here, this is c, and then you have 2 as the gradient, so this is the next coordinate of this would be most likely 0 c plus 2, because the slope of it is 2, so it moves the rise over run of it would be, the rise would be 2 times of the run. That's how I usually logic it out. But then if you don't get what I'm saying, and you prefer to do it methodologically, you can always just insert this equation with numbers. For example, y equals to m0 plus c to find y, and then you insert again y m1 plus c to find the next y, and then from these two answers, you get the first coordinate, which is 0 and c, and the second coordinate, which is 1 and m plus c. And with these two coordinates, you just need to make a line out of it, and that's how you find the straight line of the graph. And then for the it's actually pretty similar for the general form, which is an ax plus by equals d. So the easy way to figure out the equation is usually by looking for the y-intercept of this form and the x-intercept of this form. And in this case, you just need to insert a equals 0 plus by plus equals to d, and ax plus b0 equals to d. So from this, you can find that y equals to d over b, and when x is 0, and for this, you can find that x equals to d over a when y is 0. And from these 2 points, from these 2 points, you can find here and here, for example, and then you just pull a straight line, and that's how you find it. Or the third option would be just to insert the graph in your GDC, and you'll find the graph. It's easy as that. But don't ask me how to use your GDC, because everyone has their own different GDC. And for me, I'm using Casio, but I think there's a lot of people who's using the Texas Instruments, I think. I'm not sure. So yeah, just Google graph calculator name GEC, and you'll find a lot of YouTube tutorials on that. So I suppose we can get into some of the questions. Okay, so one of the first question is draw a graph of y equals to 3x minus 5. And to do this, like I said before, you just need to, how I do it is usually just like, the y-intercept is minus 5. So this is the first point. And then if it's 3x, that means the gradient, that means it's kind of like 3 rise over run. So like every time you move one coordinate, it moves every time you move one coordinate to the left, the coordinate that moves upwards or downwards is moved by 3 times. Yeah, like that. So that means that the next, if this is 1, the next coordinate would be at minus 2 right here. Oh, it's y equals 3x plus 5. I just added like this thing as like a bullet point, except it looks like minus. So usually I just do this, and then you already get 2 points, and then you just pull up a straight line that hits both these points, and you're done. But if you think that this is confusing, I think what most schools taught us to do would be to usually make a table of x and y. And for example, you insert 0 to the x, and you try to figure out the y value of it. And you kind of like do this 2 times. You can insert any kind of value that you want. For example, you want to insert minus 1, that's also fine. So, without this, by the way. So for example, y equals minus 1 minus 5. This is y equals minus 3 minus 5, which results in minus 8. So the values that you found is this, and that's how you like make your points. Minus 8, this is minus 1, and then like you're supposed to like do this. Yeah, and then after you do this, and then you make a line through the table of values that you make. It's kind of like the same thing, but I just like to do this because it's faster, and because it, for me, it's logic, but I don't know if it works for you or not. And then for the next one, we have general form. This is 3x plus 2y equals 12. Again, this thing is actually a bullet point, not a minus. It's supposed to be this. So to find this, an easy way you can do it would be to insert zeros in each of the x and y values. So you can find the x-intercept and you can find the y-intercept. So this is gone. And you can find that y equals 6. For this one, x equals to 4. And so from this, if the x is 0, the y equals to 6. 6. And if the y is 0, the x equals to 4. Then you just pull up straight line. It's just as easy as that. And a sushi restaurant nigiri costs 4.50 per serve and sashimi costs 9.00 as served. Hiroko spent total. Oh, okay. Okay, so in this question, do you guys want to try to work on this question first? Or do you want me to just immediately explain?
I think your friend left.
That's okay. I mean, I expected no one to come anyway, so this is fine.
That.
I guess I just want to like practice explaining math.
It's fine. It's going well, except the start was a bit scuffed, but we
Yeah.
can deal with the internet.
I mean, to do this question, you see that like a nigiri cost. Oh wait, I forgot to annotate this thing. You can see that oh nigiri cost 4.50 per serve. In sashimi costs $9 per serve. In I think Hiroko or whoever it is spent 45 to buy both of these. And we don't know how much did they buy, but we surely know that um the nigiri they bought and the sashimi they bought has a variable to it. Let's just assume that this is X and this is Y. And after they like buy it with a certain amount in total, you get $45. And this is pretty much how you answer number part A. I mean, you don't really have to explain. You can just explain this with logic.
Would you have to graph it?
No, we just need to explain about it. Because there's yeah, assuming this happens, there's like a lot of possibilities of how much they buy to like how much is this amount and how much is this amount to get a total of $45. And for question B, see, hypothetically, if Hiroko buys 4 serves of nigiri, how much sashimi would she buy? So for this, you just need to insert the equation, 4.50. This is the nigiri, x4 plus 9.00y equals to 45. And then 16 and 18 equals to 9y 35. Oh, 18 plus 9y equals to 45. So that's 9y equals to 45 minus 18. 45 minus 18 is 3. 20, 27 over 9. So that means that if they buy 4 serve nigiri, they would have 3 serves of sashimi. And then for the second question, it's kind of like the same thing, but you just insert the y to find the x. And then for the last question, they ask you to draw a graph of 4.5 and 9.00y. How you do it again is just to insert 0 here. To insert like 0 for x and y. And through that, yeah, the y-intercept, for the y-intercept you get 5. And for the x-intercept, you get 4.5. You get 10. And then and they also ask to insert for B and C. So you just need to mark the points of how much you got. For B, it was 4 and 3. So probably somewhere 4. This is 3. This is 4, 3. And then the other point is it's 1y equals to this is 1. Then 3, 6. That's around 40. Okay, so you get 8. So you get this is for B, this is for C. That's how you do it. Like it seems complicated, but then if you slowly break it down one by one and follow the easy solutions, it leads you to somewhere at least. And that's how you slowly find the answer. Oh, okay, so now we have perpendicular bisector. So for a perpendicular bisector, it assumes that there's a line segment. Usually you can find the equation of the line segment, but usually like a line segment doesn't like stretch forever, unlike an equation of line. It just like stops from one point to another. And when the question asks for a perpendicular bisector, usually it's the midpoint of the line. It's in the midpoint of the line segment. And the second requirement is that it's usually perpendicular to the line, like its own name. So to find the mid of the line segment, you just need to add the point A and point B. So for example, XA plus XB over 2 and divide it by 2 to find the middle. And it goes the same with YA plus YB over 2. And to find the perpendicular of it, like we covered before, you just need to use the function of m1 times m2 minus 1. It's usually that simple, but they usually mix it up with some of the properties, some of the line equation properties that you need to know. So the question seems complicated when in fact you just need to know that you have to start with like some of the previous math before doing this math. I don't know if that makes sense, but yes. I mean, honestly, I'm like really lazy to do the first few questions. I'm gonna do the last
All right,
question.
we can skip.
Yeah.
This one?
Oh, I mean, we can.
What do you mean?
I mean, the last question of the perpendicular bisector.
Oh.
Actually, which one looks hard? Is the last question or the second last question?
I don't know. Yeah. I'd say the quadrilateral one.
And that looks because you kind of need to know the properties of the rhombus.
Mm.
So this is 3/4.
Isn't it just?
This is 2/2. Okay, so in this picture, you can obviously see that this and this is parallel each other.
Mm-hmm.
Or if you want, we can also prove it by counting the gradient of these.
That's fine.
So, do you want me to count the gradient?
Up to you.
Is that so? C A B C D. Okay, to find the, let's just find CD. No. In so like before we use the rise over run. This one is 3. So that's the gradient of CD. And then now we find the gradient of BC. Which is B 4 minus 2, or 3 minus 2, which results in 2, 3 plus 2, 2 over 5. Oh, okay. This is an interesting question. Okay, so we can show that this is a rhombus by showing that these lines are parallel. And the way to do this is to calculate the gradient of it. So I've calculated the CD, and then I've calculated BC. I need to calculate something like AD or AB. It's up to you. You can do AD first. If again, the same, you just need to do the same steps to find these. There's 1 plus 3, 1 plus 4, 2 over 5. Now, I finally calculate 80, and this shows that they have the same gradient. So this shows that this is actually parallel. And because this is parallel to each other, this is also most likely parallel to each other. A rhombus has perpendicularly bisecting diagonals. Yeah, a rhombus also have a perpendicularly bisecting diagonal. That's a good point. And I think that's like what the next few questions are asking us to do. See, it's asking us to find the equation of the perpendicular bisector of AC. In AC, MAC equals, so tiny. C is 3 over 4. MAC equals to minus 3, minus 4, minus 4, minus 3. So that gets you minus 1, no, sorry, minus 7 over minus 7, which equals to 1. And then we can find the midpoint of it first, since we're going to have to find the perpendicular bisector of it. That would be minus 4 plus 3 over 2, and minus 3 plus 4 over 2. This is 1 over 2, minus 1 over 2, and 1 over 2. So to find the equation of the perpendicular bisector, we just need this midpoint and this gradient. Since the gradient for AC is 1, that means the perpendicular bisector of the gradient is minus 1. Then you just need to insert this to y equals mx plus c, which results in to find c. So you can get 1/2 minus 1/2 plus c. Equals to c, so c equals to 0. So that means y equals to x. Oh, in this case, it's y equals minus x. That's the answer of B. Okay, so since we found that y equals to minus x, to show that B and D both lie in this perpendicular bisector, you just need to insert them into the equation to see if they are equal or not. So like, you just need to insert -2/2, and this is proven. Well, here you just need to insert 1, -1. Proven, the answer is correct. Okay, now we can go into simultaneous equations. Last part of the chapter. I only have 5% left, so I hope my laptop doesn't die soon. So for simultaneous equations, you can do it by manually doing it. So you draw a graph, then you look for the lines, or you can do elimination or substitution, which is what a lot of us have learned through algebra. Or if you're an AI kid, you usually use a calculator if you're very lazy. Okay, so I'm just gonna cover the first question and show how you can do it manually or by elimination or by substitution. So to draw this graphically, you just need to, again, I mean you just need to do the one that we had before, graphing, except this time you just need to like draw two graphs and see where they meet in the point. So since this is the y-intercept is here for the first equation, 1, 2, 3, 4, 5, 6. So the next 1, 2, 3. Oh. So this would be the first graph, and then the second graph would be right here. And then you just need to pull a line until they finally intersect each other at a certain point. And that's how you find this result. And then for elimination, you just need to cos x minus 2. You just need to add them or subtract them to each other for elimination. So for example, in this, you subtract y, since they have the same variable, the same amount of variable, and you can find x. So 3 minus x equals 2x plus 4. And from this, you can find that x equals to -2. After that, you can insert x to one of the equations. For example, like this, y equals to -2 minus 2. So y equals to -4, and that's how you find -2 and -4. And then for substitution, substitution is similar to elimination in some way. I mean, it's not very similar, but the other one just needs extra algebra manipulation in advance to find one variable and then to find the other variable. So for example, y equals to 3x plus 2, then y equals to x minus 2. So to substitute, you just need to realize that since y equals to x minus 2, you can replace y with this. And that's how you get x minus 2 equals to 3x plus 2. And after this, you have to, well, you have to move it so that x is in one side and then the numbers are in the other side. Like this. Minus 2, minus 2. Through x. And you get x minus 2, and y would definitely be minus 4. So any of these ways works as long as you're comfortable with it. Number one, just do whichever you feel like you're used to doing. And number two, you can try other techniques if you want to recheck your answer. I think that's pretty much it for this chapter. Hey, we're finally done.